Good morning to everyone. So, okay, it's already 11. So I guess that we can start already with the session. So good morning to everyone. Yeah, I would really like to welcome you to this PVSITES webinar on driving the BIPV technology to a large market deployment from BIPV products to BIM modeling and applications. My name is Pablo Alonso. I work for WIP Renewable Energies in Munich. I will be moderating the session of today, but I'm not today representing my organization. I'm representing the PVSITES project together with some of the project partners that will participate during this session as speakers. So today we start with the first of a series of 3 webinars that are taking place during today, tomorrow, and the day after tomorrow, in which some of the PVSITES members will present you part of the PVSITES project results developed during this almost 5 years of project implementation. In the next slide, I would like to present you the structure of this series of webinars. So these webinars, as I already mentioned, will happen today, tomorrow, and the day after tomorrow, from 11 until 12:30. So today we have a webinar on PVSITES project contribution to BIP market. So we will try to introduce you to PVSITES project, explaining you the project objectives, the project Demosites. We will also present you the catalog of products developed, and we will also give you an introduction to the software tool that has been also developed within the project. Tomorrow, we will have a more specific webinar on the catalog of products and applications. We will have also the opportunity to have during the session to have our product manufacturers to present their technologies, from BIPV models based on crystalline silicon, so to CIGS technology, and also advanced greens interface for BIPV systems. And finally, we will close this series of webinars with a webinar dedicated to the BIM Solar tool, which is a software and web platform for simulation calculations and services for studies and promotion of BIPV solutions. It is now time to present you the agenda of today. But first, I would like to introduce you to the speakers during this session. So yeah, together with me, we have also three consortium members. We have the project coordinator, Eduardo Roman. We have also Thierry Yenga from BRIT. He's our architect within the project. And we have also Philippe Alamy from CAD-Camation, who is in charge of the development of the PVSITES software tool. I would like to also remind the participants that all the project reports are available in our project website. You can access in pvsites.eu, and you can also follow PVSITES on social media, on Twitter, by tracking our hashtag PVSITES. As per the agenda of today, so the session will be structured in 5 sessions. So we have this one that I'm already doing, this presentation of the PVSITES webinar. We will then follow this session with the session dedicated to the PVSITES project, which will be presented by Tecnalia. Then we will have a session on the introduction to the catalog of products and introduction to the second webinar, which will be presented by Tjerk. And then we will also have a session on the introduction to the BIM software and the introduction to the third webinar presented by CAD-Camation by Philippe. We will close the session with 15 minutes for the questions and answers. So it's now time to remind the participants that the chat for this session has been turned off, but you can write your questions by using the icon on the bottom of the screen, the questions icon. Please indicate the organization to whom you would like to address the questions. We will collect the questions, and we will answer them during these 15 minutes of questions and answer. Please also be informed that the session is being recorded, and the slides and the recording of the session will be published in the website shortly after the series of webinars. So, having said that, yeah, I think it's time now to start with the presentations. So I would like to really kindly introduce to our project coordinator, Eduardo Roman, to present the PVSITES project. So Eduardo, you can now unmute yourself. I will display your presentation, and then the floor is yours.
Thank you, Pablo, for your kind introduction. Hello to everybody. Yes, my name is Eduardo Roman. I work for Tecnalia and leading the PV group, the photovoltaic group here in the solar area of my company. And as Pablo has explained, I am the project coordinator of PVSITES project. PVSITES project is a project that started 4 years ago and is about BIPV, Building Integrated Photovoltaics. So it's about construction materials and products producing electricity at the same time, or with this multifunctional aspect. So first thing we have to say is that the BIPV technology or systems has been pushed and by the PV sector in general and by the European Commission in this case. Traditionally, so the European Commission has put a lot of effort and even budget in this technology since, I don't know, since the beginning of the century, I would say. As Europe sees BIPV as an opportunity to recover the PV industry in Europe, so it means local content, it means European jobs, and also is a way of achieving these near zero energy buildings. That it will be mandatory in a few years, and a way of achieving the full decarbonization of the society by 2050, which is included now in the Green Deal. I have to say also that the effort pushed by the Commission has followed different stages. At the beginning of the century, the idea and the effort was to make the technology more visible, so with a lot of dissemination and communication activities to make known this technology to citizens, even to the photovoltaic community. Later on, in 2010, the efforts were to try to overcome the existing barriers, legal, technical, standardization. And when this project started in 2016, and this was the main objective of this project, the idea was to provide solutions and to give answers to the market needs, to the requirements coming from the market, from the business aspect, in order to increase the share of BIPV in the whole PV installed capacity. So now I think we are still below 2% of BIPV total installed capacity with respect to the total PV capacity. So and it's clear that we all see a lot of opportunities in our cities, in our buildings, to include these systems there. So we have to see, and this was the idea of the project, what can we do to increase this percentage, to increase this ratio, and to put more BIPV in the market. So going to the presentation, this is the index of my presentation today. So first, a very short introduction of PVSITES project, including the objectives and challenges that were established at the beginning of the project. And then I will focus on the main achievements and results extracted from the project, including also the few examples of successful products that are already in the market. So a very fast overview of the project, as I mentioned, has been funded by the European Commission and also by the Swiss government. And in total, around 7 million euros of funding, started in January 2016 and will end in next week, so in 2 weeks, after 4 years and a half. There are 15 partners from 9 different European countries, so a very European-wide project, covering, as you see in the picture, covering the whole value chains of the technology. So including all the phases from the market to the design, specifications, development of products, energy conversion and management, testing. So we are companies, we are research centers, we are universities. big companies, small companies. At the end, it's a mix of European companies in this consortium. So, the main objective of the project is to achieve the large market deployment of this technology of BIPV, led by the European industry. And how this will be achieved, or has been achieved in our case, because we are already ending the project. First, identifying and addressing the market needs and business requirements for the BIPV, and very important for us to demonstrate in real buildings, as you will see later on, a portfolio of BIPV solutions in which we have already included simulation, integration, performance, grid management, LCA analysis, and a lot of activities around this portfolio of solutions. Solutions that not only cover modules, as we all may think, but the whole value chain. So modules, BOS, the balance of system, including power electronics, energy management system, and additional tools like software and others. So at the beginning, in 2016, we also identified the market challenges. Although they were established or they were fixed in 2016, I think most of them are still valid and are applicable. For instance, the need of flexibility of design in the BIPV solutions, including or incorporating the aesthetical value, the multifunctionality, and the cost effectiveness of the solutions. The need and the necessity to help to assist architects and designers in this design phase through a simulation of BIPV product together with the building energy performance. Also, once we have produced electricity, what we can do with it inside the building. So at the end, there is the need also of a more predictable, manageable, and green-friendly photovoltaic generation of electricity. And finally, a market challenge was the demonstration that all these solutions perform and are reliable enough to be included in real buildings. For each of this challenge, the project proposed a solution, a combination of activities and solutions. For instance, if we are mentioning the flexibility of design as a need, considering the aesthetical value, what we proposed is a portfolio of BIPV solutions, modules in this case, based on two technologies, crystalline silicon and CIES technologies, with two different manufacturers, Onyx Solar, Spanish one, and Frison, the Swiss one, on CIES, accomplishing with the market needs. If we are saying that there is a need of a software tool able to help and to assist designers, architects in these initial phases, and including BIPV solutions, what we have proposed in the project and we have developed is an accurate and user-friendly integrated software tool platform for the simulation of these BIPV products, working with BIM models and structure, and including also the possibility to analyze the energy performance of the building after this photovoltaic calculation. All these tools will be explained later on. I think today will be introduced, and tomorrow or after tomorrow, there will be a specific webinar for this tool. If we are saying that we need a more predictable and manageable electricity generation coming from BIPV, what we are proposing in this project, and we have already achieved, is a combination of high flexible and high efficiency grid interfaces for BIPV systems. And here we have included power electronics, so in this case, inverters working with storage, and a combination of tools and building energy management systems. And finally, if the need is to demonstrate the reliability and the performance of these solutions in real buildings, so what we have proposed in this project is a set of real buildings, including industrial, residential, commercial buildings, and even infrastructure, as you see, the carport in Zurich. for demonstrating the performance and using these demos as a way of showing the rest of community and citizens how these systems are working perfectly, of course. So about this is just one slide to show how we have implemented the PVSITES project. First, establishing the needs from the market and from analyzing the business cases, defining special business cases for BIPV, and also analyzing the market needs, including also legal requirements and standardization requirements. Once we have or we identify these needs, what we did is to develop solutions for these needs. In this case, module solutions like CIS from Plisson and crystalline silicon from Onyx Solar, and also power electronics and these building energy management systems, including also the software tool we have explained. And finally, we have tested all these developments in real buildings. So it's a typical process in a project: first requirements and needs, then developments, and then testing these developments in real buildings. So in terms of achievements, and starting with the market-related activities or achievements, well, we have
I think Eduardo.
And we assessed the regulatory framework. This was also carried out at the beginning of the project.
Sorry, Eduardo. There was a shortcut.
Oh, sorry.
30 seconds. So
30 seconds. So sorry. Sorry. I will then repeat. So in terms of achievements for the PVSITES project, I will start by the market-related activities and achievements. Most of these achievements are in the way of reports and are accessible in PVSITES web, so you can download them. So at the beginning of the project, we conducted a market and stakeholders analysis and assessed the regulatory framework. The regulatory framework is something that is very active, let's say. It changes a lot and depends a lot on the country, but we did, and we carried out one at the beginning of the project. We analyzed, and by that time, there was a new standard for BIPV, which was this 5583. So for the first time, we have applied this standard to BIPV products within the project. We identified exploitable results coming from each partner and analyzed the different commercialization roadmaps and the paths for protection the IP. And well, I think also very important, we analyze and we try to invent different business models attractive for all the stakeholders around the BIPV. These business models have been cross-checked with also with the International Energy Agency, Tax 15, and I think they are being now tested in the real business. So in terms of modules, I will separate the achievements first with crystalline silicon glass solutions developed by Onyx. For instance, Onyx have achieved and have developed different solutions. Examples: hidden bus bars or L interconnections. So making these modules more attractive to the end users, playing and making modules with back contact cells and see-through glass solutions with large formats. This is something that is required by architects and these commercial buildings, and glazing treatments like mirror effect or filter effect. In CIS on metal substrates, these solutions were developed by Plisson, and they have developed different roofing shingles so CIS on steel and roof tiles on different metal sheets, as you will see later on, and large area flexible membranes for roof and facades. And we also have developed not at commercial level, but at research level, different semi-transparent, low concentration solutions, playing with transparency with Fresnel lenses to allow light enter into the building depending on the season of the year for a passive control of the building. This has been developed by Tecnalia and by Onyx. Well, these are different pictures of the glass crystalline silicon solutions. You will see here, well, these back contact cells or this blue tinted glass module or the specular effect. In this slide, you will see this large scale or extra XL format module. I think it's like 4 or 5 square meters, the picture in the left. And also, not at the commercial stage, but we also, or not we, Onyx and Frison tried to develop a solution for making glass module with CIES with a curved solution. The curvature is not so much, but well, I think you can see this curvature in the picture in the right up. Well, I think I guess this solution is not in the market yet, but has been tested in the project. So for the semi-transparent low concentration solutions, well, these are different pictures of the solutions. We have developed 2 different models, one for facades and another one for roofs. I think the one for roofs is working better than for facades. To work better means that we produce more, spending less. Is more or less what we want to achieve. So, but in this case, the idea is not as we are adding different external elements like these lenses you see in the pictures. At the end, it's obvious that the cost will be increased, but what we have to achieve is more energy produced by the PV cells, as we are achieving a kind of low concentration. We are deviating the rays to the cells, so a small concentration on the cells. So we are producing more electricity, but it has to be compensated with the extra cost. And in this case, the numbers are not so good for the facade. On CIES, these are different pictures of what we have achieved. I think these pictures will be better shown by my colleagues later on. But well, these are different roof shingles and roof solutions on metal substrates developed by Frison company. I think these solutions will be also shown tomorrow in the webinar tomorrow. And other achievements, for instance, these modules in outdoor testing in Acciona. Acciona was another company in the project. Well, you see here different tests. Not all of the tests have been in real buildings. Here are like mock-ups, special designed for testing these solutions. As I mentioned before, we applied the new standard BIPV, European standard, to our solutions. I think it was the first time because it was just after the approval of this standard with very good results. In terms of energy conversion and management, so we are not in the modules part, we are in the BOS part. So we have developed 2 different solutions for PV inverters working with storage. One developed by Tecnalia with DC coupling, so the storage is coupled in the DC side after the PV panels. Another one is made by SEA Ines and is made from silicon carbide components, so showing high reliability, efficiency, and cost reduction. In terms of strategies for improving the energy management in the building, we have also developed different solutions, making or trying to optimize the use of electricity produced by BIPV in the building. So, for instance, in developing different forecasting tools for to know which will be the future generation of BIPV and which will be the future consumption of the building. And mixing both aspects, trying to make good use of the electricity produced. Following with this energy conversion and management achievements, here, for instance, we have already developed a planner tool. This is at the end is a kind of software that is very useful for sizing PV systems with the storage. So, as you know, the storage nowadays is the most expensive element in the PV system with the storage. So we have to try to size very good very precisely, accurately, the size of the batteries in terms of kilowatts and in terms of kilowatt hour. And we have to make good use of these batteries, trying to extend the lifetime. So this is made mainly by algorithms and by including forecasting tools, knowing when the battery will be used with 24 hours in advance. And well, all these strategies for the building energy management has been developed also in the project and has been tested in real buildings with very good results. Well, this is the tool for BIPV design and energy performance simulation. Will be explained later on by CAD Commission, so I will go very fast through it. And finally, and we are very proud of these achievements, is the installation of all these solutions in 7-8 real buildings. We have considered all type of buildings, so commercial, residential, single family, multi-family residential buildings, industrial buildings as well, and carports, and even tertiary buildings like this, Colotelier in Geneva. So few pictures about these Demosites. I think my colleagues will focus more on this part today or the days after. So this is the single family residential building in Belgium. It has been a retrofitting of the roof, and here we have installed the CIES tiles with this very nice aspect at the end. So this is a carport in Zurich. In Zurich we have developed 2 different carports. This is made, or the PV element is a CIES flexible element. So as you see, we can achieve these curved surfaces. Also very interesting. And in this case, the use of electricity is for helping in the charge of these electrical vehicles that are behind the carport. This is another example of carport. This one in Dubendorf, also in Switzerland. This is an industrial building in Spain, in Cricursa. It's a glass. It's a glass manufacturer, curved glass manufacturer. So this solution is also provided by Frison. These are roofs on membranes covering the roof. So with very lightweight solution, very easy to install. So the advantages are, I think, very clear. This is a social housing residential building in France, in Batins, close to Lille, and it's also a retrofitting example. So in the left you see the initial aspect of the building, and in the left you see the final aspect, although it has been changed nowadays, I think. So the picture in the right is not the final aspect. I think it will be changed a lot. No, not a lot, a bit. But it's a ventilated facade made of crystalline silicon glass solution provided by Onyx. And this is the example of an office building in San Sebastian in Spain. This is the headquarters of Tecnalia. In the left, you see the initial aspect of the facade. We had, and I say we because I work in Tecnalia. We had a problem with the light coming into the building, especially in summer. So a lot of light inside. We included even a filter inside the building to avoid the light inside the building. So we decided to make this ventilated facade made of crystalline silicon technology provided by Onyx, and in this way we are like making this heated effect directly without adding additional elements inside the building. Well, very important for us is this protection, and also for the Commission who put funding for this project, is this protection of our developments in the real world after the project. So, and I have to say that although we have not finished the project yet, we have already achieved different exploitation results. For instance, the planner tool developed by Tecnalia has been licensed and sold to a radio frequency station, or for the use in radio frequency stations to UNESCO in Spain. Also, coming from Tecnalia, we are under exploitation agreement negotiations with the electronic manufacturer here in Spain. The Beam Solar, which is the commercial name of the BIPV design platform, is already online in a free version. It will be explained by Philippe later on. During the project, there was a collaboration between two partners, which are Onyx Solar and R2M solution, for the commercial development of Onyx Solar solutions in Italy. So R2M has become the official distributor of Onyx Solar in Italy. And finally, Onyx Solar and Frison has put many of the products that have been developed during the project in the market, as I will show right now. So these are, for instance, the products developed by Frison, CIS products, is in a retrofitting example in Netherlands with the eFlex, is the commercial name of the solution product. This is a 180 kilowatts roof in Netherlands. Or this one with the same product in a flowers market in Johannesburg in South Africa, also provided by Frison. This solution is provided by Onyx. It's a black thread module and has been installed close to Buckingham Palace in London. This one is the 16 kilowatts BIPV glass installation facade with blue tinted solutions provided by Onyx Solar in Balenciaga storefront in Miami. This installation has been awarded with the most innovative curtain wall project in the USA in 2019. So we are very proud of, and Onyx, of course, very proud of this award. And more examples with products directly developed within the project. This canopy in Czech Republic, also provided by Onyx Solar with blue tinted glass. And I think the last sample I want to show here is the headquarters of Lego in Denmark with this PV skylight provided by Onyx, 450 square meters of modules. What we see in the picture is one of the 11 cycles that compose the PV installation. This solution is made of opaque glass, where the front glass is glass in acid with acid edge, and the rear layer includes black thread solution. I think if that's all from my side. Well, apart from these results, here from there we'll present the eCarport, which it's a very important result coming from the project. And also very important is the job we have carried out in terms of dissemination and communication. We have produced, I don't know, maybe 40 public deliverables that are accessible in the web. We have achieved almost or over 70,000 downloads of this report, so a very good and incredible success for us. We have produced leaflets, dissemination material, videos of the installation processes, So you can have a look in the web and access these videos. I think they are also in YouTube and in these channels. And I think that's all from my side. I hope you will have now a better idea of what we have achieved in this project, and that's all. Thank you for your attention.
Well, thank you so much, Eduardo, for this presentation. I think it was a very complete presentation on all the project activities. So I think you gave the audience a very clear picture of what PVSITES is about. Yeah, I can underline what Eduardo was saying about videos and dissemination activities. You will be able to see some videos indeed on the demo sites of the project in the project website. So I can invite you to visit the website and also to of course to subscribe if you want to receive more information on the project. So thanks again, Eduardo, for this complete presentation. You actually stick on time, so that's perfect. Yeah, to the audience, if you have any questions, please write them using this questions icon that you have on the screen, and then they will be answered at the end of the session. I think now it's time to start with the next session of this webinar, which is on the introduction to the catalog of products and introduction to the second webinar. I would like to kindly introduce Tierk Yenga from BIR ID. He is one of our architects in the project. So Tierk, I'm going to display your presentation, and then you can unmute yourself, and yeah, and the floor is yours. So.
Thank you, Pablo. I will say next because I cannot steer myself. This is a little too far. Can you start with the first one?
Yes, yes. Sorry. Okay, so here's the presentation. Just let me know, Tierk, and I will do the slides for you.
Okay, yeah, this is the first slide, and then go to the next one, please. Yes, I'm a little far away, so it's a little slow, I guess. The introduction I want to give you is actually that about the online catalog of products, and also the PDF we make that you can download. I will talk about that later. Within the PVSITES project, as Eduardo already explained, there's a lot of pictures. We made a pretty big portfolio. At least 10 BIPV products, actually a little more, but I keep it on 10 of the main products. And 2 inverters are developed within this project. Beside that, there's a software developed, and these 3 days will actually focus a lot on the software as well. The software is, of course, to support the design process and also to apply the products that we developed in the building projects. Actually, later you will see the online catalog of products, how it is developed. And besides the products of the PVSITES, there will be more products in there. So it will be a growing online catalog of products. Next. These 3 days, today I have about 20 minutes, though that's the biggest part, and then it's tomorrow 10 minutes and another 10 minutes. I will give the introduction. Actually, I will focus first on the commercial products. That means it's about 6 of the 10 products. And tomorrow I will go on with the other products we have developed. And the day after, I will talk more about the design and the introduction to the software that you can use, the BIM Solar software. Next one. This one you can skip because I think this is wrong. Yeah, this is the good one. Yeah, actually, one of the tasks in the project is the development of a product portfolio. What you see here is actually the deliverable. It's deliverable 9.17. There's a lot of deliverables, as you can imagine. And what it does actually is this product portfolio is actually translated into the eCarport, so the online catalog. But besides only the online catalog, we also make it as a book. That means that what you see here on the picture is the dummy of the book. It's not, it's almost finished, but it's not completely finished. And from, we think next month around July 15, it will be downloadable, and you can read it on your computer, on your screen, or if you want to print it, you can even print it out. The quality is pretty okay, I think, for that. And of course, you can find all the original research reports that are behind this product, behind this PDF. You can find them on the PVSITES website. Next. Yeah, next. This is the title. This is the front page of the PDF. Next one, Pamela. Well, we start actually with the introduction, and if you click next, then we will see how the book is built up. It's actually, every product is separated in 3 parts. First start is the data sheet that describes the product and gives the data about dimensions, about the weight, the power, electricity, etc. This type of information is given for each product. Second, we have a chapter about the design description that describes actually how this product is used in one of the demonstration projects and how the design process went. So you can actually see what is the problems we have to overcome, and what was simple things and what have to be improved. Actually, this is I think very useful. And the third part is about the installation of the product. It shows more about the what really happened on the site of the demo projects, how it was installed, and what lessons are learned from this process. Next. Altogether, I have 12 chapters in this book, so the introduction, etc. This page, and then we go to the 6 main products. It's already mentioned by Eduardo, and we have the inverters at the end. And in between, actually, there's something about overview and design process, etc. And next page. So the different products in this book that are explained in this book is the Fleezone products. It's the eRoof for shingle for the sloped roof. It's eRoof industrial for the flat roof. It's the eCarport. It's the carport roof. It's a banded roof. We have the eFacade used for cladding existing buildings. And then we have 2 products of Onyx today. That is the eFacade, is used for cladding facade in a multi-family house. And we have the e-glazing that is used for the double facade in the office of Tecnalia. Next. Yeah, this page connects. This is actually the pictures of the demonstration projects, belongs to the different type of products. Next one. I think, yeah, this is the design process. I will talk about it the day after tomorrow. So I will explain a little how this works in the design process step by step. Also, then I will talk about the PVSITES software. So if you can go to the next one, I will introduce the first product and the first demo project. That is actually the eRoof BIPV roof shingle from Fleezone. Next. So first you see the data sheets. Is actually there's a page with a nice picture that shows the project, and then we get the real information, different description, mounting system, dimension, etc. I don't explain everything to you, but I think this is self-explaining. Next page is the electrical description of the product, and then we go to the next step. It's the drawings of the products. Sometimes there's just one drawing, sometimes because this is only one product, but sometimes you have different dimensions, and we put all the drawings in this presentation. The next one. The next is the design process. Well, what you see in the design process is actually the house was built in 2015, next one. And it was built as a passive solar house. The architect is part of this project, and he used his house as a demo site. Can I see the next one, Pablo? With the 2 roofs beside each other, and he used this one. And actually, he used that roof for the application of this roof shingle. There was actually one problem. There is already the house is people live in the house, so you cannot do everything what you like, of course. And actually, there was a chimney in the middle of the roof. And then actually, in the design, you have to find out how to solve this problem. Actually, the manufacturer first said, okay, we just cut out some pieces. So then we have 4 metal shingles. Is a piece cut out. That is not very nice to do, of course. So me together with the architect of this house who lived there, we tried to find other solutions. And actually we find a solution by defining actually the zones where we put solar and where we didn't put it in. And we find out it was possible to make the solution B. And in solution B, you can see that we have 3 arrays, and the first one is of 3 rows, and then we have 2, and then we have 3. In this way, actually, we get a kind of aesthetical solution. And in the space on the right side, I think if you click, you can see a circle. The one on the right side, you can see that that this was the solution where we have the chimney fits very well between the modules and without cutting the modules itself, only cutting the cover in between. Next one. This is a circle. It's yeah, it goes a little slow. Next one. The details, maybe go directly to the next one because it's zoom in a little more of the details. The special thing of this was how to combine this in a simple way. And finally, we use a kind of click system. And on the right lower corner, you can see in the 2 colors, 2 different shingles, and you can see how they just click together. That means actually that you have to start mounting the lowest row of modules first, and then actually you go up to the top of the roof. And in this way, it's a pretty easy way to do this. It was not so easy actually the first time, but especially the first row is very important because you have to line it out very well, because if the first row is something is wrong, then everything that comes after it also goes wrong and you have to start over again. But actually, finally, it succeeded, and the result is actually also pretty nice to see. And next one. Yeah, that is actually the circle is the detail where you connect the next one, connect different ones. Fleesom gave a kind of description for the electrical design. It's a kind of standard description, so we can skip it. I think you can just read it if you want after you download the book. The next one. The inverters used here is actually, there's actually one inverter and a battery used. It's the project developed by Technalia. Actually, tomorrow it will be explained more in detail, but you can see it's a pretty neat installation. Also, it looks very clean and pretty to have in a one-family house. Next one. And for the design, also used the BIM Solar software, and this is just give you some idea of next one of how you can use the software. It will be all explained more in detail, so I don't explain it now, but it just tells you what is the content of the book, and it also gives you the possibility to check the output of your system. So you can check it for one module, you can check it for a row of modules, you can check it for the whole roof or for the whole year. There's a lot of possibilities how to use this software and generate the outcome that you need. Next one. Next one is about the installation or the commissioning. Yeah, it's okay. This is also, I think, something to read yourself if you are interested in to know how it really worked. It's pretty different in different projects, of course. The next one, go to the installation. Yeah, these are the guys doing the job. You can see also the details. So you can see that in between where we have that cutter area, you have a kind of metal sheet that that connects the two rows of modules. Well, what the architect did is first he took off his old tiles. Then he took off all the lattice, and he made a new roof on top of that. And the lattice is actually made, the wood structure is made in the way that it supports the aluminum profile system very well, so that it's easy to add all the roof shingles on the roof. And you can see here, this is they're measuring everything, and then on the second picture is actually the first row that is the most important row to get it exactly in the place where it has to be. Next one. This is some more details of the profiles and how they use the profiles. There's also some extra support because there was without the support the span of the modules is actually a little too much, and it should be, well, it shouldn't give a very nice and flat image, of course, as you can see it in the picture. Now it looks really pretty nice. And if it's bending a little, it doesn't look very nice. So there was an extra support that was actually not foreseen in the beginning, but later find out it is necessary to add this extra support. The next one. And then for the maintenance, Fleesom also give for all the products a general guideline for inspection and maintenance of the modules. This is also for each project we will give this information. Next one. The next project, it's a little slow for me. Yeah, here it is. This is the flat roof. It's the BIPV element, or it's the industrial eRoof from Fleesom. Next one. It's starting with the table, of course. I think Pablo just go very slowly from the one to the next one, and then go to the design, because then I can explain a little more about how it all come together. The tables and the drawings are, of course, part of the PDF, so it's in there. Yeah, this is the table. This is the drawings. The next one. Go to the design. For the design, actually, we had an existing roof. That existing roof is a kind of a sandwich panel. It's 1 meter wide. It's a kind of polyurethane inside, and it has a here you can see it in the SketchUp 3D drawings that he made, and actually the ribs of it are 50 centimeters, so it's 500 millimeters in between. We can span it actually with the PVSITES elements. Problem is actually that 50 centimeters for the thin metal structure is, for the thin metal sheet, is actually a little too much, so we have to add a profile in the middle. There's also two options. So one option was actually to make it as low as possible, so you have a kind of a big water cutter, and the other option was actually to make it the opposite way. The option B is actually easier to produce by Fleesom, so actually option B was chosen, but it means you have a higher profile in the middle. Next one. And here you can see that element, and you can also see the overview of the roof, how it was designed. Because it's an existing roof, you have to think about how to divide everything between over the roof, and also the yellow part is the sandwich, that's insulated panels, but in between you see the stripes, it's a light blue stripes. That is actually light, it's a plastic windows actually in the roof. So we cannot do anything there. And in between, we also need some space to walk over the roof for maintenance, etc. Next one. We can think you can just go on to see the pictures, yes, and go on to the installation. Electrical design. Oh yeah, for the electrical design actually is also a kind of a balance between the different strings. There's 4 inverters added. 2 inverters are commercial inverters, SMA inverters, and the other 2 inverters are SEA. It's the PVSITES SIG inverter. You can see here how they calculate the different rows to balance actually the amount of power for each inverter. And next one. There's the calculations with the software. Next one, go to installation, no problem. The installation was actually done in the summer last year, and actually it was the hottest time of the year. It was almost impossible to work on that roof. So that means the normal working days from 8 hours a day was actually pretty reduced, I think, because it was too hot to handle there. Here you can see how the mounting system, the installation is working. Actually, in the edge of the module, we have to make some holes because the sandwich panels are actually screwed on the structure, on the steel structure under it. So that means they come out. It's not flat. You have these bolts coming out, and you have to put it your module over it, and then the hole has to be a little bigger so that you have some possibility of expansion as well. Then actually, if you do so, then you can start with the next step is actually you screw it on one side, and then actually you take the next one, go over it, and you screw the next one on over it. And the one in the middle actually is at the end of every module, we screw it on the supporting profile that we have in the middle. And there was 2 options, but actually option 1 was the most easy to do. So mostly we choose option 1 for that. And actually in this way, we just do row by row. You do the 1 row, and then you do the 2nd row and the 3rd row, and you go on over the whole roof. It's actually pretty easy way to construct everything on the roof. Next one. Yeah, this is the picture. This is the picture how it is and how it was designed. It's more or less what you see. The only thing is that we designed it actually with a profile on to cover everything with a rubber, and because of the existing screws that was not possible to do it. The first problem is that we had to design it before we could really see the details of the roof, because you're not allowed to go on the roof itself. But later, later in the stadium, we find out it's different. So we have to make the holes in the module to fit over the existing bolts. Next one. Yes, the maintenance. Go to the next one. It's going pretty slow for me. Yeah, this is the carport BIPV carport elements. Next one. Start with the data. You can just go one by one to the design part, Pablo. It's done by Friesen. Both carports are built in Zurich. One is built at EMPA, and the other one is built at EKZ. It's the utility. Pretty nice, pretty neat roof. You can see it here. The design of the roof is actually, the design of the whole carport is actually based on an existing carport by a local company. They make already this type of structure for carports. So what's happening, you have a concrete base. On the concrete base, you mount the poles. Go to the next picture. You mount the poles, and over the poles, actually, you make the horizontal profiles that make the whole system, the whole structure stable. And then actually over this, you just mount your modules. There are 2 modules needed to cover this. Can you go to the next one, Pablo? To cover the whole roof. Yeah, just go on one by one. Yeah, to this. So, and these two are actually connected first. So that means from the two models, you make a very long module, and that one is actually screwed on the structure. And next one. Only just commercial inverters are used in this project. Yeah, next one. Here you can see that how the split is made between the different modules. They are exactly extended to a very long module. Next one. Yeah, this is the calculations. Also, for every project we did a calculation. We explain in the book how it was done in the steps. Next one. Commissioning. Yeah, go to installation. Yeah, this is halfway the installation. You can see here that on the right side, the construction is there. On the left side, it's already mounted. Next one. This is the different steps of the whole installation to the final one. It's actually going pretty fast. On the moment that the main structure is built, then the photovoltaic roof is actually done in one day. It's really something that goes really fast. And under the roof, there's a cutter, and all the cables are connected and combined in this cutter. Next one. Yeah, it's about the maintenance. It's also kind of standard about the maintenance. Next one. I think looking at the time that I should skip actually, well, not skip, but I will replace it to tomorrow. The two projects. So this the BIPV facade here in the École Hôtelier in Geneva. This is actually the last one I want to explain, and then I want to stop so that we can go on tomorrow. Next one, Pablo. Go directly to the design. Just show the pages and then go to design. Yeah, the tables is the basic information. There's much more information, of course. There's actually from every project. There's in the data project. There's about 5 to 6 pages with data, but actually for the to start using these products, actually you don't need all the data at once. So what I try to do is in this product is actually to give you the information that you need when you start using the product. What you see here is actually the school. It's the main building is a restaurant. It's the original building, and then several years ago, I think about 8 years ago, they have this extension. It's a partly underground extension, and it has 2 pavilions on both sides. So now it looks like a building with 2 wings, and it's connected and with a small courtyard in the middle as well. Both buildings on the left and on the right. On the left is building 1, pavilion 1. On the right, pavilion 2. You can go to the next page, Pablo. These buildings had a red brick, and that was actually one of the problems we have in the beginning, because it was very difficult to get permission for the cladding of with a black facade elements, because the image of the school from red to black is a completely different view, of course, completely changed. But okay, finally it was after several discussions with the local authorities, it was accepted, and the permit was given. And then actually it was in the middle of the holidays, and it was not possible to start the work, and then we had examinations. So at the end we had some delay with the installation of this project. And the installation is actually pretty simple. We put vertical profiles on the facade. And then actually you can see there's a kind of hanging system. It's a kind of hooks on the corners of every module. And we just hang it in and then we can put we can fixate it so that it cannot taken out, or it cannot start moving by wind or something like that. So it's a pretty simple system also, and pretty lightweight system. So it's very easy to do this on an existing facade. Next one. Yeah, this is the total picture. This is the area, so you can go on to the installation part, Pablo. Electrical design. Yeah, go to installation. Well, the installation was actually the software, and then installation was actually, when they started, it was pretty easy to do. There's actually one thing is that if you look to the modules, then the amount of modules is actually smaller than the wall, the red brick. So that means that at the edges, we have to make a kind of hooks that cover the small part of red wall and that connect actually the module with the hook to the window frames, also black window frames. Otherwise, you should see some red brick behind it. That's not very nice to see, of course. Next one. And then it's actually after everything was finished and was commissioned. Well, the process, the start was pretty slow, but finally it was all done and it's all finished, and it looks a pretty nice project. I want to stop here, Pablo, because otherwise the time is getting too long, and I will go on tomorrow.
Yes, thanks, dear. That's perfect. Yes, as you see, or the participants can see, this kind of catalog is going to be very complete with a lot of information. So as Tier already mentioned at the beginning, this is being finalized at the moment. I've seen already that some of you are asking about when and where it's going to be available. So it will be available in the project website, and we still need a bit of time to finalize it. I've seen also some interaction with questions here, so I will maybe at the end of the session I will just read them loud for all the participants to know what the discussions were about. So I think right now we can indeed jump into the last session. It's the introduction to the BIM software tool and the introduction to the third webinar. In this case, I would like to introduce you to Philippe Alamy. He works in CAD Commission, and he's responsible for the development of the BIM solar software tool. So, Philippe, you have 20 minutes. So please try to also stick on time, so we have at least 5 minutes at the end to read loud the questions indeed. So, Philippe, the floor is yours.
Yes, thank you, Pablo, and good morning, everybody. I will try to make my best to shorten a little bit and to save time for questions and answers, because I guess there will be some. Thank you for attending, and I know some of you attendees in the room, of course. You are already BIM Solar users, so I will present shortly our experience with PVSITES project. I'm a member of CAD Commission, PVSITES project partner in Switzerland, based in Switzerland, Geneva. And you can join me, of course, to learn more about our findings. Sorry, Pablo.
Sorry,
Maybe we have to start again.
1 second.
Okay. Okay, control it now. Yes. So, why did we join this project? What is the objective of our meeting today? PVSITES plus CAD Commission. CAD Commission joined the PVSITES project because we have a great ambition since several years. It's to translate into the building industry what we had experienced before with the manufacturing industry, called product life management. And because of the innovation with BIM in the building industry, we had the idea to lead researches and developments and merging solutions to enable to couple element level modeling and building level modeling together with a complete workflow called the product life cycle, from design to exploitation and to end of life as represented. So this is clearly the topic and the ambition for Catamason and the reason to get into the PVSITES project focused on the brand new BIPV product innovation. So Catamason is now has now a larger ambition together with Arcade System, sharing his value and revenues between reselling BIM solutions and developing new assets. PVSITES, as I said, has the ambition of merging prototyping solar products and also renovating buildings, facade roofs with new materials, replacing new materials, old materials by new materials, sorry, together with, of course, technical and regulatory requirements, leading to good business condition and good economical conditions. So this ambition is ours, and of course we decided to deal with building integration using digital innovation together with solar simulation, one of another strong asset within Catamason, and of course leading to produce virtual digitized version of BIPV products. And this is supported by BIM, meaning building information modeling, the leading innovations from the past 20 years for the building industry. The meeting purpose of today is present our work shortly and open perspectives with next webinars. We're gonna go into details on Thursday about the software and tomorrow about the virtual products. And of course, fostering BIM innovation for BIPV is our ambition today. The challenge for this product was to follow horizontal and vertical workflows, integration from element level to building level for any kind of product, and you discovered the real innovations, real products with CHERC just before. The solution based on the BIM Solar free for use software today is a new version of the software and a comprehensive portfolio of virtual products, what I call an e-catalogue of BIPV virtual products that I will present shortly and more in detail tomorrow. You can see some pictures of the Demosites right now. What is PVSITES software based on BIM Solar and what is the role of BIM for BIPV? PVSITES is a BIM software and then is a BIM innovation. So based on BIM Solar software, we decided to go deeper into BIM and to be BIM ready for you as user of digital solution. This is explained in the next videos and next slides. So I will start this video presenting you the typical modeling process using the software. First, and we did that with CHERC, of course, we have to catch and the local conditions. So we are in the need of generating good inputs, weather data based on the location, and we need a 3D model. So this work is represented with SketchUp, a non-BIM solution officially, but also compatible as a 3D geometry with BIM solutions today, and enabling us to generate a simulation model. So we import it into the software, as you see, and we localize the weather data. And this contextual location or weather data enable us to avoid landscape detailing because we already get the horizontal masking effects. We can get a good sun cross, and we can focus on the 3D design of the building itself with some surroundings represented on the like boxes in this video. We are able to detail also albedo effects by setting the values for albedo for surroundings and even other buildings or parts of your building. And then you can run a radiance simulation to understand much more about the shading effects or the potential you can get from, in this case, your roof. And this is, these are annual value or daily values, and you can, of course, analyze the shading effects and avoid some issues for your future installation. The software enables you a full graphical use and even deal with some seasonal periods or average day within the year. So even on this step, you've got a lot of useful information, and you can play it as a what-if analysis. So in this case, we analyzed the shading effects of the chimney. Then to build a BIPV layout, as explained by Tjerk, we need to understand what is the ambition of the architect and the owner in this case. And we start to design with virtual objects, building a portfolio of virtual elements, virtual products. We start to set up them with datasheets from the manufacturers, and then we start to install it as, in this case, tiles, roof tiles from Flissom on the roof in a graphical way. So it's very easy to design a roof, and then to get the right number of modules at the right position, and then generate shading effects with simulation and size the effects as shading at module level, and you get even the irradiance and the yield at module level. You get also global KPIs, main KPIs for PV production at array level, and you can analyze every mismatching effect before inverter production, so you can anticipate and avoid the issues, of course. And you can start to talk, of course, with the engineers and to build the balance of system for your system, BIPV solution. The video stopped, maybe, I don't know why. Sorry, but maybe the video stopped in the middle, so maybe I have to go back, sorry. Yes, so you can analyze at model level, but also at array level. You get global figures, hourly figures, monthly figures, any kind of time step you can analyze and get figures and get exploitation in CSV values of your generated outputs. You can also go deeper into BIM from manufacturer datasheet, creating the virtual object in a beam compatibility, beam readiness. And this was the main achievement of the PVSITES project for CAD-CAMation. So from a kind of mechanical representation of the product, you can get into what we call, with Autodesk solution, Revit families. You can build Revit families fully compatible with the simulation workflow and the digital workspace. And this was the main innovation by CAD-CAMation during this project, and soon available for users with the final publication of the virtual catalog, in line with the real catalog of products. So the main achievement are visualization and parametrics of the product, and I will go through very quickly with the main providers. Flissom for thin film CIGS products. This is a Revit family of the cladding for École Hôtelière de Genève. So the beam readiness is fully obtained today, and compatible, of course, and built into the Autodesk Revit solution. We will go into details, of course, tomorrow, product by product. This is the eRoof tile from Flissom. These products will be available on the web platform and on the web storefront for you users of the BIM Solar solution. You will get them on download to build your own PVSITES database. This is a short presentation of the storefront. So you can add to cart your virtual product as a traditional online shopping platform. And this is also the innovation for PVSITES. This is the rendering, of course, of the FDD house. The next family of products are crystalline silicon products from Onyx Solar, semi-transparent, for instance. This is the Revit family for the X6, sorry, transparent products. The challenge was to get, of course, the good features for the glass performance, transparencies, visible aspect or so you can see the mix between real products and virtual products, and the configuration of the products within the BIM Solar software. And of course, the use of this kind of product is today a reality on the commercial market. So our ambition is now to get used as virtual product to anticipate this kind of installation. About the inverters, 2 inverters were developed, as you know, one from CA and one from Tecnalia. Virtualization of inverters are a bit less visual, but they are also a reality into the software, because the need of getting a new next generation of inverter is important for anticipating the performance of every building in renovation. So we did that, and we will provide also in the final catalog, commercial catalog, these 2 innovations: the charging DC coupled inverter from Tecnalia, and the silicon carbide inverter from CA. And they are embedded into the software. They are not real BIM objects because there is no demand for representation of this kind of material today. Modules are more important because of 3D modeling, of course, but they will be present in the workflow. Just to quick review every demo site, you know the reality of each of one now. So we used the general features from the architects and from the BIPV expert to be able to build our simulations and our BIM versions of the buildings and the objects. So this is the single family house in simulation with objects. These are the repeat families of objects installed in the roof, and the replication is completely coupled, and this is the innovation, the BIM innovation for PVSITES. From creating the virtual object, you can get it into your roof at the right position that you decided in the simulation workspace. So design is coupled to simulation. This is the final result, of course. Same for École Hôtelière de Genève. This is the simulation workspace. And you can see also the virtual objects and the final version of a cladding aspect in Revit solution. Carports, the challenge was to create bendable products, and we did it. The simulation is, of course, supported by the 3D modeling, because the curved models are analyzed, and irradiance is simulated and distributed with the ray tracing technology we have embedded into BIM Solar to provide distribution of solar energy on the totality of the modules of the carports. And you can see the detailed analysis and also global KPIs. And the result, of course, industrial building, it's a bit easy for us, but we, of course, created the virtual model, the Revit family of these fully integrable models into industrial roof. And you can see the simulation workspace also providing high irradiance significance, of course. The real result. A special case, of course, with a renovation of a facade in France, in Wattignies, using Tegnalia inverter. So we did the full simulation. We let holes, as you can see, between modules, because we didn't represent dummy models. There are dummy models just for a nice appearance, but this is not necessary in the simulation workflow. But of course, in the BIM final representation, you can also create dummy models as you want. And the product from Onyx Solar is called X5 in this case. And of course, the main challenge here is to stick to the stage of the renovation process. And the stage is before complete renovation of the building. And the ventility facade has also features integrated in the software with the thermal models. Last model is the office building for Tegnalia, with 2 facades and a new object, the X6 object, semi-transparent, for transparent glass from Onyx Solar. So you can see the rendering and the virtual family in Revit, and the final result. So in my conclusion are that we put main efforts on virtualization, good virtualization of the products, good enough to offer a very quick rendering between simulation and BIM integration. The collaborative digital workspace is now ready to be published for you as user between design, simulation, calculation, and of course a web workspace to find within the community the objects, the catalogs, and to discover the process as category by category and innovation by innovation. The BIM readiness from element to building level is a reality today. We are BIM ready for Autodesk Revit. We are also BIM ready for Open BIM, like IFC format, or IDF and GBXML energy modeling format. And I will speak about this innovation also on Thursday. The web platform, as I said, is soon open to retrieve every digital asset that I presented. You will be able to download them and to get them and discover them clicking on beamsolar.com, and the public release will be the 1st of July. Thank you for your attention, and now I guess we are opening the questions.
Yes, thank you, Philippe, for the next presentation, and thank you also for taking time. Yes, going just to open 1 second. Okay, and then I have seen that there was already some interaction on questions, so I will just read them loud by order. So yes, there was one question from one of the participants asking how does Onyx Solar hide the bus bars and L connections on glass crystalline silicon solutions? Well, this is a good question, but I guess that yeah, Philippe was already answering. This question will be better answered tomorrow during the webinar, because we will have one of our colleagues from Onyx Solar indeed participating in this webinar and presenting their technologies. I've seen also one question here from Yuri. I'm sorry, from one of the participants. The question says that it was showed a Manhattan complete city image simulation on some of the slides. Is it any free source for complete architecture cities, or the only option is to model it from scratch? I guess that Philippe, you have the answer to this question, so you can maybe say something on that.
Yeah, for 3D modeling at city level is very impressive, and always a target for a lot of users. So there are some communities like a 3D warehouse for SketchUp, very easy to provide you downloads for cities like Manhattan. I always use Manhattan. You just need to be careful with the rights of use for these models, but for personal use, it's okay, or educational, or research and development use. And of course, the ambition is to provide 3D modeling from any public source, like Google Maps or OpenStreetMap or Open Mapbox, and we are in this ambition also to provide our users to get a 3D model nearly in instant way by coupling a solution to generate extrusion of the city and immediate analysis of shading and solar potential on a city. We can use also some sources and some other innovation, and Marco mentioned so one attendee mentioned a public source also in this way. So we have several resources, and there will be innovation in the next year for sure.
Okay, thanks, Philippe.
But datasets are already, some datasets are already available.
Yeah. Okay, another question was about the PDF file, that when it's going to be available and where. So this was already answered, that it will be available on the project website, and we expect to have it within the next weeks. I have one last question from one of the participants. He's asking about, yeah, he's saying, has the Flisson tile a Navis technique from CSTV? Well, I think that's this also a kind of question that can be better answered in the webinar that will take place tomorrow, because also Juliana from Flisson will be indeed participating, and we will present in detail our Flisson products. So I'm sorry that maybe I invite you to also to register to tomorrow webinar and to participate on that. So there is, let me review. I think there is no more questions. So I just wanted to shortly present you the webinar of tomorrow. So the webinar of tomorrow will be more specific webinar on the catalog of product and applications. So we will present the BIPV models based on crystalline silicon, CIGS solutions, and also the inverter and BMS, etc. So here you have a picture of the speakers. So we will have a lot of time to interact with everyone, and you will have also time to ask your questions directly to them. And yeah, I think that we can already close the webinar here. I'm sorry for the 5 minutes delayed, but I really appreciate that all the participants were connected until the end. So I kindly invite you to stay tuned as well, to visit our website and also to register to tomorrow's webinar. So I wait for you tomorrow at the same time. So thank you so much for your participation. I will thank you also to the speakers for your nice presentations, and see you tomorrow.